Hi everybody, myself is Nochiketa Acharya. I'm an assistant research professor in Department of Meteorology and Atmospheric Science at Penn State University. Today I'm going to talk about our ongoing work on GAN-based multi-site weather generator. To start with, I want to make a concept what is weather generator. Weather generator is a stochastic model that produces long time series. It has a huge application. Is actually the overall method of this weather generator is start with observed data, then it has lots of statistical model, and you can generate lots of weather generator, generated sequence. So the applications has a wide in weather generator, mostly used for the climate change impact in hydrology or crop growth modeling, where they need a huge weather data set. And it can be also used for the statistical downscaling of climate change impact studies, or it can generate ensembles for the natural climate variability. So it has a huge application for these stochastic weather generators, and the research have been done from 18th century, but most of the popular weather generator based on Richardsonian model, which is published in 1981. So the main concept of the methodology of weather generator is wide as well. Most of the study actually focusing on precipitation generate, because precipitation is very unique. It has occurrence and it also have a intensity. So it is two-stage modeling, and there's a couple of different methods available in the literature, like parametric, semi-parametric, non-parametric, curve fitting, and also has a lots of different methods for maximum minimum temperature and other variable like solar radiation, dew point temperature, wind speed. So if we just explain what was the classical approach by Richardson, mostly for the rainfall, it has a two-stage. One is occurrence process and one is amount process. So occurrence process mostly based on Markov chain, which is a probability of rainfall depend on the immediate past. And once they decided those occurrences in terms of probability, now they're fitting different kind of distribution to get the amount process. But it has a huge limitations. Those classical weather generator limitation include that they are less efficient for simulating extreme precipitation. And the bigger limitation is actually they're unable to present the spatial attributes, because most of the weather generator is actually single site. That means those weather generator doesn't have the information about the spatial coherency, and which is a big problem, especially on watershed modeling or crop modeling, where we have a lots of different station, and it's important to have the information on the climate or different station. So on that point, our objective to actually explore our idea whether machine learning can develop a multi-site weather generator where we can keep the spatial attributes. On that, we choose a deep learning model called Generative Adversarial Network. And the reason behind we choose it, it's actually a very unique, because it it's comprised rather two submodel. One is generator, one is discriminator. The generator actually generate the random data, and discriminator actually classify whether it's a fake or real. And this is a very unique method. It's recently developed, and I think it's one of the best method in recent past. As the director of AI of Facebook also said the same thing, that it's the most exciting development in last decades. So just a little bit of more on that, like it has a two different network. First, a discriminator understand what is real and fake, then generator generate lots of synthetic data, and based on that synthetic data, discriminator classifier, and this is kind of keep on going on until unless generator make discriminator false. The math behind this whole GAN is actually relies on a mix-match game. So it has a two different component. One part is like discriminator prediction from the real data, which always want to be maximized, and another is like the generator part, like which going to be minimized. But if you look at the equation, is 1 minus, that means at the end is maximize the whole part. So this is a kind of ongoing. So we are working on that and making a new generator, new weather generator based on GAN. But the question is, why GAN? Why not the other method? First of all, it's a non-parametric method, so it's no assumption of overall distributions. And also it's not based on only resampling, because some of the weather generator based on resampling, but there's a huge limitation on that they cannot make a new scenarios. Another thing is like it generate more realistic data, as I mentioned in the method that generate and is discriminator. They always like, uh, play with each other to get a realistic data. And another thing, like it can learn from a smaller data set, because it's a huge limitation of using a deep learning in climate data, because most of the cases you don't have a huge data set. But this particular method can also work on the smaller data set. On that note, we just want to apply this weather generator in an existing problem. We choose a New York City primary water supply problem because it's a very unique. Mostly like 90% of the water for New York City comes from the upstate watersheds, which is from the west of Hudson watershed, and it's kind of a gravity pool and no filtration, so they reserve this area. So that's what, like, that the Department of Environmental Protection wants to do a real study on climate impact on the water quality and water quantity. That's what, like, it's very important. And mostly like the study on this particular area, which is northeast, we found that it's going to be more wet, because it has a lots of chances of having a frequency of extreme more, which has a huge problem in terms of increase of sediment erosion or increase of nutrition loads, changes in the annual cycle of the reservoir thermostructure, which actually impact of water quality huge. So that's what, like, it's an ongoing study. And in the previous study, we actually work in different kind of weather generator based on statistical methods. And then we run the watershed model, and then we actually generate different scenarios. But the huge limitation of those previous study is like we are working on a single site. That means although it has a 6 watershed, we actually making this weather generator independent from 6 watersheds, so there's no information between the watershed in terms of spatial attributes or correlation. So that's what we want to test, this whole GAN-based weather generator multisite, that whether we can actually get those things. So we kind of go different layers of implementation. We use 20 values as a sample from a normal distribution as a latent vector to start the network. We use the popular ReLU activation functions, and we can actually running 10,000 synthetic data with their 6 outputs features corresponding to each watershed. And we implemented this thing in a monthly mean data first before we go to the daily, because we want to test whether it works at least, then we can go for high resolution in temporal scale. So based on the data, based on the result we have up to now, is actually look like this. So if you can look at the box plot of the monthly data or monthly rainfall distribution for each of the watershed, it look very similar to the actual synthetic. But our main target to see whether they keep the correlation. We also look at the summary statistics, and we found, the extremes are really captured from these kind of things, but we are mostly interested on these results. So the left-hand side, you can see the heat map of correlation between the watershed from the actual data using the last 60 years of climate. And we use the same data to generate this synthetic data using GAN. We found they keep the exactly same kind of correlation because it's a multi-site, so it's actually keeping those correlation. So that's what, like, we found our whole hypothesis, keeping this multi-site weather generator using GAN is actually works, and we can tested it. And as I said, it's ongoing work. We're still working on making it a more high resolution temporal scale, like daily. So on that note, I must say thank you very much. And on that, I really thankful if any feedback and comments. Thanks.